Okay, we'll take a look at example number 7. We have a triangular cross sections. So if you look at this figure here, it shows a solid with a circular base of radius 1. Parallel cross sections perpendicular to the base are equilateral triangles. We want to find the volume of the solid. So let's take the circle to be x squared plus y squared equals 1. So the solid, its base, and a typical cross section at a distance x from the origin are shown in the following figure. So here we have a cross section that forms a triangle. In this case, it's going to form an equilateral triangle, meaning that it has all angles that are the same. And you can see here, if you look at this origin, you have going from -1 to 1, and now you've created these cross sections that form these equilateral triangles. Now, if you notice here that the circle is in the form of x squared plus y squared equals 1, and what we want to do is, just like we did in our previous examples, we want to solve for y. Solving for y of this equation gives us the square root of 1 minus x squared. And so the distance from here to here represents y at a point x. So this is the base. And then the cross section is an equilateral triangle. So we know that we have 60 degrees here, same thing here. So if we know that this is y, then this becomes the square root of 3y. Now, since we know that B lies on the circle, again we have y is equal to the square root of 1 minus x squared. And so the base of the triangle ABC is the absolute value of AB, which is equal to 2 times the square root of 1 minus x squared, because again you have a plus and a minus version of that on your circle, and you're going to be multiplying that by 2 since you have 2. Now, since the triangle is equilateral, we see that from the figure 13c here that its height is the square root of 3y. And we know that y is equal to the square root of 1 minus x squared, multiplying it by square root of 3. And so the cross-sectional area is therefore the following. The area of the cross-section is 1/2 times 2 times the square root of 1 minus x squared times the square root of 3 times the square root of 1 minus x squared. Multiplying that all out is going to give us the square root of 3 times 1 minus x squared. And now what we're going to do there is then we're now going to integrate from values of -1 to 1 of that function. Taking the antiderivative of those and multiplying it by 2, using our -1 to 1 going from 0 to 1, meaning you have 2 equal areas, is then going to give us a volume of 4 times the square root of 3 over 3.